Okay, let's have a look at 27. We've got a fractional thing here. We've got a pair of brackets on the top with two terms in each. So we better write down the rule for expanding brackets then. A plus B times C plus D. And for that, you draw two lines for the first, two lines for the second. Line 1, 2, 3, and 4. So let's expand that bracket then. We're going to get four terms. The first line, product, is AC. See it there? AC. Plus the second one, that's AD. See it there? Third one, CBC. So I'll put that down. And then the last one, fourth line, is B times D plus B. Hang on, the third line is BC. I'll get it right in a minute. So let's just overwrite that. And then the fourth line is BD. Okay. So there we are. Little bit of bookwork there. The expansion brackets rule. So now we can expand the bracket. So I think we'll do that without further ado. So y equals then. So we draw two lines for the first, two lines for the second. Lines 1, 2, 3, 4. Now the first line is 2x times 2x, yeah? Which is 2 times 2 times x, which is 4x squared. Next line is 2x times 1 lot of 2x, which is plus 2x. Then we've got the third line, minus 1 lot of 2x, which is minus 2x, yeah? And then the last line, minus 1 times plus 1 is there. Minus 1 times plus 1. Minus times a plus is a minus, 1 1's a 1. And that is all over x, isn't it? So we're getting there. So let's write that down once more. Y equals 4x squared. The two middle terms will cancel each other out, won't they? And you'll have 0, and then the minus 1 at the end. All over x. And now this thing is fractional in its nature, I suppose you could say. So if you write down a fraction, 3 plus 4 ninths, that would be 3 ninths plus 4 ninths. So we can see how we can split that up, can't we, just by writing a simple example down. So when you split up a fraction, 3 plus 4 ninths like that, it would be the first term over what's underneath plus the second term over what's underneath. So let's do that here. The first term over what's underneath is 4x squared over x, plus the second term over what's underneath. We've got a minus there, so it's going to be minus, isn't it? The second term over what's underneath. There we are. Now we'll put the powers in explicitly. X is really x to the 1, because we're going to invoke the rule for indices here. Divide you minus top take bottom. So there's that rule. And I'm going to put in another rule, which I'll squeeze up here. X to the minus a equals 1 over x to the a. That rule then, let's put a box around it, because we're going to use that rule as well, aren't we? So let's tidy up a bit more then. Divide you minus top take bottom. We got power 2 take power 1 is 2 minus 1 is 1. So it's 4 lots of x to the power 1. Bring that up to the top. It's minus 1 lot of x to the minus 1. So everything now is on ground level. Let's just tidy it up. Y equals then 4x minus x to the minus 1. Now we've done all that process now to tidy it up. Now at long last then we can differentiate it. So dy dx equals x goes to 1. That's that rule there. 4 lots of 1 is 4. And then the minus comes to be with the other minus to make plus 1 lot of x to the minus 2. So I'll just put it here. That's equal to then 4 plus 1. And I'm going to drop the x to the minus 2 underneath with this rule here and flip the index to an x squared. There we go. So we've got 4 plus 1 over x squared. Then we do at x equals 1 then. Dy dx equals 4 plus 1 over x squared. And now we overwrite the input, the x value of 1. 1 squared is 1. 1 over 1 is 1. 4 plus 1 is 5. There we go. That's the answer for 27. Let's move on. 28. Next, believe it or not.